I think one more problem is left in this. One more part is left in this. So the last one is find P of x greater than or equal to 1 by 2. That means the probability that x takes a value greater than or equal to 1 by 2. That means 1 by 2 and so on. So that means if it is a continuous random variable, then we have to go for 1 plus 2 plus 3 like this. In case of in case of continuous, what we have to do is, so 1 by 2 to the upper limit. Upper limit here is 1. So that is how we need to find the probabilities. The same here. So actually, what is the interval that it takes, or it lies in the interval -1 to 1 by. So where suppose we divide this into 2, one is half here. That means we divided this into 2 intervals. One is -1 to half, and other one is half to 1. Why we are doing is, here we want to find the probabilities which are greater than 1 by 2. That means we need to find the probabilities of x taking a value in this interval. Okay. So that means what happens now, we are going to find the probabilities in the interval half to 1, not in the entire interval. If we take the entire interval, then we will get 1 only. Clear, I think. So we know that the total probability in the interval is in the interval -1 and 1 is 1. Now we want to find out what is the probability that it lies in the part of this. That means which is the part half to 1. So that means we have to take the integration, that is from half to 1. Half to 1 f of x dx. Same of f of x is cx square, where c is 3 by 2, and x square dx between the limits half and 1. X square integration is same. 2 plus 1 is 3, therefore x cube by 3, and we have to substitute upper limit 1 and lower limit 1 by 2. So from this we get 7 by 16. So total probability is 1, but in this half of the interval, the probability is 7 by 16. And repeatedly, what we have been discussing is, whenever we find the probabilities, you just validate, is it satisfying the rules what we are having with respect to probabilities. What are those 2 rules? One is probability always lies between, particularly about that one rule, probability is always lying between 0 and 1. Okay? It should not be more than 1, it should not be a negative. So whenever we got this 7 by 16, whether it lies in the interval 0 and 1, because probability can't be negative, probability can't be more than 1. So like this we have to validate, particularly in examination. This is one point which is helpful for us to validate whatever we have done. Okay. So is it clear? Okay. So then we'll take it further with can you please help us to understand the value of C? How did you do that integration? Value of C is already what we got at the beginning. In doing the problem, already we calculated C value, right? This is C value. Okay. That means now once we had C value, f of x becomes 3 by 2 x squared. No C actually. How to get C is the same. So we have to use that validation property, integrating this between -1 and 1 cx square and equating this to 1, because total probability is 1. Right? So that's why here C is whatever we used is from the A part. Right? The C is taken from A part, that is 3 by 2. Previous slide, okay. How C has derived to 3 by 2? This one. So very simple. -1 to 1, the interval in which this lies, and we know that total probability is 1. So this, right, we have to integrate this and equate it to 1. So while doing so, c is a constant which we take out, and integral of x square is x cubed by 3. So which is again equating to 1. Now we have to simplify the LHS, where we have to substitute upper limit as 1 minus lower limit as minus 1 as shown here. So c by 3, upper limit minus lower limit, and this becomes 2, 1 plus 1. C by 3 into 2 is 1 and c is 3 by 2. So this is how we calculate c value. So I hope that integration, I think this integration is very simple, only this formula. One more formula maybe we require, that I'll explain whenever it comes. So please make note of this formula. So this formula x square, that means n equal to 2. So then integration becomes sorry, 2 plus 1, that means x cubed by 3. If n equal to 3, x power 3 plus 1 by 3 plus 1, x power 4 by 4. Like this we have done. Very simple, they only this formula. If you see here, x power 4, 4 plus 1 by 4 plus 1, therefore x power 5 by 5. Okay. Here also you see here, x square dx, x power n equal to 2, so 2 plus 1, 3, so x cubed by 3. Like this we do. Okay, then we'll move to the next one. Why was there a division? This is a division is n plus 1. This is a formula. I think we don't get into that derivation kind of how to have the formula. This is the formula. Just this is the one which you have to use regularly. X power n is nothing but x power n plus 1 in the numerator by n plus 1 in the denominator. When x square, x cubed by 3, x cube, x power 4 by 4, x power 5, x power 6 by 6. This is how we do integration. Why we have taken limit from minus 1 to 1 is because f of x is defined in the interval minus 1 and 1 only. That is the reason. So in the rest, except in this, if you see here, this is the interval in which the function is defined, f of x is defined. Rest all it is on zeros. That's why in all our discussions we have taken the limits between minus 1 and 1. That is the reason. So here dx is not becoming 1. Dx is something which says that it is integration. Right? So how this dx is not becoming x actually? It is formula here, x square dx, where x square dx stands says that we have to integrate with respect to x, and formula n equal to 2, therefore 2 plus 1 x cube by 2 plus 1 x cube. Right? Just you can go through it and don't hesitate, like if there is a small doubt, big doubt, any kind of doubt we can discuss later also. That is not a big problem. Yeah. If anything is there, we'll discuss later. We'll proceed further. So next comes, now I hope we are very clear with respect to random variable where we had discrete, where we'll have continuous. Random variable I'm saying. So whenever random variable is there, where we'll have discrete and continuous. Whenever we say discrete, we'll have p of x. Right? Whenever continuous, we say we'll have f of x. Right? Now, depending on p of x, there are many distributions defined. Depending on p of x and some properties related to it, we'll have various kinds of distributions. They are called as, that is what we call as probability distributions. So probability distributions, it depends on how you define or how it is defined, how p of x is defined, depending on some names, binomial, Poisson distributions, which comes under discrete. In case of continuous, we had the most popular distribution, which is normal distribution or Gaussian distribution. The communications, the guys who are into communication, ECE kind of stuff, they popularly call this as Gaussian. Or in most of you, like who are working in as software engineers, you are very familiar with one term called as bell curve, right? I hope bell curve is very popular. You are using for many things in your organization, which is nothing but the same. Bell curve is something related to normal distribution. Okay. So now, it is clear. Depending on P of X, there are various distributions. Here it is many are there. We took most useful, most frequently used distributions. That is, in case of here, it is binomial. One is binomial. If any random variable whose probability distribution function P of X is given as this NCX P power X Q power N minus X. So P of X is defined as NCX P power X Q power N minus X. Then we say, or then we call it as binomial distribution. If P of X is defined as e power minus lambda power X by X factorial, then we say it follows Poisson distribution. Like this, P of X is some A minus B by N something, then one formula, one name. Like this, the distributions are defined based on P of X. Okay. Now coming to this, what is N, what is X, what is P, what is Q? So N is the total number of trials, and X is total number of success, and P is the probability of success, Q is probability of failure. Okay. So that is how the binomial distribution is defined. And here, general when you start implementing in various by using various tools, the most important things that we have to know is what are the parameters which defines binomial distribution. What are the parameters of binomial distribution? The parameters of binomial distributions are, one is N, that is total number of trials. Other one is X, that is total number of success. It is something like I am tossing a coin 10 times. I am tossing up a coin 10 times. What is the probability of getting tail 5 times? Right? So that means total number of tails N is 10. X is related to getting heads. Right? That is success. So where here X equal to 5. Right? So N is total number of tails, X is total number of success, and P is the probability of success. What about Q? Q is probability of failure. Probability of failure, how to find? 1 minus P. Right? We know we discussed at the beginning. So probability of success plus probability of failure together total is 1. Right? So I repeat here. In case of binomial distribution, what we have to remember is what are the parameters that defines binomial distribution. The parameters are, one is N, that is total number of tries, and second one is X. What X stands for? The number of success. And third one is probability of P, that is probability of failure. But if you consider Q also as a parameter, it is not correct. Only 3 parameters are required for binomial distribution. So why not Q? Maybe actually you have to pose the question. My say is only 3 parameters defines binomial distribution. Right? Can you contradict this? Can you contradict my statement? Yeah, Q is, we can't say, because once P is available, Q is automatically available. So this is nothing but probability of A is Q P, then probability of A bar is 1 minus P of A, that is Q. That's why Q is not a separate parameter, right? As I here. So Q is 1 minus P. This is the probability of failure. Q is equal to 1 minus P. So that's why it is not a separate parameter. So only 3 parameters defines binomial distribution. Okay, right. So next, Q is 1 minus P. Good answer. Yeah, good. So that is very important, particularly when we start implementing. So what are the values that we have to define? What are the parameters we have to declare? So N, X, P. Then Q automatically takes from the data available. Now we'll just quickly go through binomial distribution. When it follows, next comes is when it follows binomial distribution. So some points. One is when the number of trials is fixed, like n equal to 10. That is, coin is tossed 10 times. And second one is each trial results in either success or a failure. Right? So every trial, like you have to get either head or tail. Head is maybe you are looking for success. That means head is success. Getting a tail is a failure. Right? So that's why every trial must result either in success or a failure. Next, trials are independent. This is another important point. Trials are independent. I think you know the probability of getting head in the second instant is not depending on the first instant. Okay. Therefore, the trials are independent. Next, other one is the probability of success or failure remains constant. Suppose the probability of success getting head in the first instance is 1 by 2. After 10 and any x equal to 10 also, the probability is 1 by 2. That means the probability of success or failure is constant throughout the process. Then we say the trials, whatever we are doing, are called as binomial trials. If they are binomial trials, then we say it follows binomial distribution. That is another reason. Another way to define the binomial distribution. Just try to understand. Don't get feel like we are having so many things like just how to define binomial distribution, what are the things behind binomial distribution, etc. Right? But finally, what you have to remember is binomial distribution is something where it is NCX, P power X, Q power N minus X. What is N? What is X? What is P? That's enough. Okay. Now this is another way of defining. That is, if these when a trial satisfies all the properties, then the trials are called as binomial trials. Then the corresponding distribution is called as binomial distribution. Now, if you want, we can have how the formula is defined as derived. Otherwise, not required. Three is not possible. That's why if you remember, this is called as binomial distribution. Binomial. Every time you will result in either 1 or 0. That is success or failure. That's why then only this is applicable. Then only this is applicable. It is not like in a case like yes, no, don't know. Right? Suppose if you are doing something where you have 3 options, yes, no, or don't know 3. In that case, we can't follow or we can't apply binomial distribution. Binomial is, that's why the name itself is binomial. So this, I think maybe you go through it. I don't want to make more confused by adding more stuff. How the formula is defined, you can. Which statement can you repeat? Which statement I can? I think Madhuri Trivedi, like what? Which statement I don't get? see, I think maybe I think in the maths, maybe this week, Tuesday or Wednesday, we'll spend some time where if those who are interested, you can attend so that I'll explain this NCX. Permutations and combination I'll explain along with integration. So NCX is nothing but it gives the combinations. Here if you see out of n trials X are successful, that means here if you see P probability of success, probability of success, probability of success like X times with that, right? That means P power X. And rest n minus X are failures where every time the probability is Q, therefore you will have Q into Q, so on n minus X times. Therefore you will have P power X into Q power n minus X. But when we do the trials, they are not going to be so systematic where first one is success, second one is success like this. You will have various combinations, right? So that means how many ways we can have these combinations, that is defined by NCX. That's why this is the formula which defines binomial distribution. But don't get confused with this. If you are able to follow this, fine. Otherwise, just forget it. Simply focus on this. Right? If you are interested, not able to get, let me know. I'll explain. Right? So this is binomial distribution and what is n, what is x, what is p, what is q, how to find q, and next is what are the values that it takes. Because total number of trials are n, x stands for success. So what are the values that it takes from 0 to maximum? Maximum is n. So therefore, x takes values from 0, 1, 2, so on up to n. C is not constant, it's called a combination. I think I'll explain this separately in the math class. N is total number of trials. Yeah, we'll see in real time where we apply the applications. So no proofs for this. This is just for you to understand. Right? What does alpha represent? Alpha is not there anyways. No alpha, I think. No alpha in binomial, I didn't see. Yeah. This is one, I think NCX is one term called as combinations. Like simple example I can say is you have to select the cricket 11, right? 11 members you had. Now 11 you can have like openers 2 and next third player 3, player 4, player 5, player 6, like this you have, right? But this is not the same order, right? This is what called as picking permutation. Now this you can have various combinations, right? Instead of Gautam Gambhir and Kohli opening the innings, you can have some third person coming as an opener like this. Various combinations we can have, right? With 11 players, we can have various combination of the teams, right? The slots. How many ways that we can have is denoted by NCX. That is how many combinations we can have from n, that is total n with respect to x. That is called as NCX. Right? This total is one expression, NCX. Right? For further clarity, I'll take one extra session where I'll explain the math related to it. And formula for NCX is that I'll write it. N factorial. The formula to calculate is n factorial by n minus x factorial into x factorial is the formula to calculate NCX. This is the formula. I think I forgot to mention this, which is useful. Factorial. So this is the formula for NCX. This is. Okay. This is NCX is completely one term, one representation. Yeah, I'll explain, man. Definitely, I'll explain. It is same as NCR. Instead of R, we use it here. X. That's it. It is same like NPR, NCR, which some of you remember saying. Yeah, n factorial by n factorial by n minus r factorial is NPR. That is permutation. This is combination. Yeah. I hope that it's clear, right? Why we have to consider the total process. We have to see the success as well as failures, right? Because it both are there in the entire trial, right? Therefore, P of x as well as Q of n minus x also comes into the distribution. Okay, x is looking like alpha, right? X is total number of success. Like out of 10 trials, what is the probability of getting 4 heads? X is 4 here, n is 10 there. Now, shall we go further with one example? Yeah, thank you. So this is an example which we can try to understand the process. Okay. So very simple. Each of 6 randomly selected cola drinkers. So this also comes under an application where you can understand. But finally, it's not that easy to identify that I need to follow binomial distribution. Very for a period with practice, we'll understand which distribution fits into the problem which I am trying for when you talk about applications. Right, 6 randomly selected cola drinkers is given 2 glasses. One is the glass containing cola S, one type of cola, that is S, and other one is one type of cola containing F. Right. Okay. The glasses are identical in appearance except for a code on the bottom to identify the cola. Suppose there is no tendency among them to prefer, that is, there is no fixed pattern for them. Right? I have to pick this, not like this. Randomly they will pick. Then what is the probability that out of 6, 3 prefer yes, at least 3 prefer yes, at most 1 prefer yes. This is what we have to find. What is the probability that 3 will prefer yes, at least 3 will prefer yes, at most 1 will prefer yes. Yes means the first type of cola, glass containing first type of cola. So how to do this? How to model this problem? Now here if I say, now what is the process here, right? What is it? One is total 6 randomly selected cola drinkers, that is n equal to 6. And what are the trials they are doing? 2 types of glass are there, pitching glass. Either it may be glass S or glass F. But here if you see the problem, here the discussion is with respect to S, right? That means we define the random variable X is nothing but getting a glass with cola S. Right? X is a random variable related to getting a cola, getting a glass with first type of cola, that is yes. Okay. Now what we have to find here is 3 will prefer, that is what is the probability that X takes 3, and at least 3. What is the probability that X is greater than or equal to 3, similarly at most. So like this we have to find the probability. So here, can you think whether this falls under binomial distribution or not? Can you think whether it falls under binomial distribution or not? And what are the parameters here, and what are those values of parameters? And I think it is very clear, n equal to 6, right? N equal to 6. X values depends on the problem. First problem X value is 3, second one is at least 3, third one is at most 1. What is another parameter we require here? What is another parameter we need? P, right? What is P here? Can you guess? What is P stand for here? Probability of getting a glass containing cola S. What is that value? Any guess? Yeah. 0.5, because there's no choice, but both are having equal probability of getting. Therefore, P equal to 1 by 2. P equal to 1 by 2, 0.5. Yeah, perfect, perfect. So every trail will result in either S or F, but here with respect to this random variable, S is success, F is failure. S is success, F is failure. That's why every trail either you will get S or F. That means every trail contains either success or failure. And the probability of success is 1 by 2, failure is also 1 by 2 at any given time. That means it is constant. Therefore, it follows binomial trails. Therefore, we can use binomial distribution to model this problem. Now, getting into further, just very simple. Once we are able to identify the parameters, very simple here. N is 6 and probability of success 1 by 2. Automatically, Q is also 1 by 2 probability of failure. And just getting into the problems, 3 prefer yes. That means P of X equal to 3. So what is the formula here? What is the formula here? Here NCX, right? P power X, Q power N minus X, where N is 6, X is 3. Probability is success is 0.5 and Q is also 0.5. So therefore we get this. Okay. It is 0.5 is not because of 3 by 6. It is because they are saying both are having equal chance, because there is no tendency for them to prefer one polar to other. That means if both are having equal chance of being preferred by the persons. That's why probability is 1 by 2. Suppose if it is something like 60% of the people prefer to take polar S than F, then P equal to 0.6, Q equal to 0.4. Clear, right? Second one, at least 3. At least 3 means greater than or equal to 3. Greater than or equal to 3 means P of 3 plus P of 4 plus P of 5 and P of 6. I think this is not there. Right? So we need to find all these properties. We'll get it. Or otherwise, P of 0 to P of 6, the total is 1. Right? We want only from 3, 4, 5, 6, or we can use this formula also. Don't get confused with this. If you are comfortable with this, use this. Otherwise, go for this. Okay. Because very simple here. Now, X takes values between 1 and 6. 1, 2, 2, 3, 4, 5 and 6, right? 1, 2, 3, 4, 5, 6. Now what we want is P of X greater than or equal to 3. That means 3, 4, 5, 6, 3, 4, 5, 6. This is actually this property we want. That means one way is at 3, what is the probability of 3 plus probability of 4 plus 5 plus 6, like this we can find. Because we know the total probability is 1. Right? From the total probability, if we remove this small probability, then we'll get. So that is nothing but P of 0. I think one more missing here. Sorry, something happened. This is 0, this is 1, this is 2, 3, 4. I think there is some error while explaining. 6. Okay. This is now it is clear. I missed 0. Now probability of greater or equal to 3 means what we have to do is this part we have to take. From 3 onwards we have to take. So this one 3, 4, 5, 6. This is. So probability of 3 plus 4 plus 5 plus 6 we can calculate. Or otherwise, because total probability is 1, if we remove, if 1 minus P of 0 plus P of 1 plus P of 2 we take, then we'll get this. This is the second formula. 1 minus P of 0 plus P of 1 plus P of 2, from which we get this 0 minus. So at any point of time, they can take only one glass at a time. One glass they will pick, either it may be yes or yes. So after the second one, third one, very simple. At most one. At most one means less than or equal to 1. That means P of 0 plus P of 1. Just using the formula where n is the same, n equal to 6, x is 0. We have to do the calculation, x equal to 1, we have to do the calculation, we get this. So this is how the binomial distribution is composed. Is it clear? Or any doubt related to binomial distribution? P of 0 same, nc 0, p power 0, q power n minus 0. Why P of 0 comes is, if you remember, in binomial distribution, x takes values from 0 also, because all are not, right? Getting is because total number of trials are m, the probabilities are getting 0 also is there, right? Getting 0, getting 1 success, getting 2 success, getting 3 success, or getting maximum success, that is m. Therefore, P of 0 also comes into picture. That is what I missed in my explanation earlier. Okay. So is it clear? So don't feel that we have to remember so many. Very simple. Finally, just 2 lines only we need to remember in terms of binomial distribution. This problem is something where to understand the formula and how to apply it. Otherwise, nothing is complex and complicated here. So is this with replacement or without replacement? That's a very good question. Whether glasses are with replacement or without replacement. If you remember the earlier discussion with respect to play cards, if you remember our earlier discussion with the 2 same words, replacement or without replacement. Here one good question is asked. We are picking the glasses, right? In the process, 2 types. One glass is picked and keep it out and pick the another glass. Or pick the glass, put it. That means every time we'll have 6 glasses when we go for the trial. Whether it is with replacement or without replacement. If you remember, we discussed 2 cases. With replacement, without replacement, we have dependent and independent. If you remember, in binomial, we always look for trials which are independent. When it becomes independent, always with replacement. Right? With replacement, then only you will have equal probability of getting either yes or yes. It's a very good question actually. So every time, at any point of time, we will have 6 glasses only. That means we will pick it, check whether it is yes or yes, again we will put it. So maybe while doing so, if you are not able to understand the NC3 kind of stuff, I will explain it separately. So that I need some writing to explain it. I will use pad to explain it. So math requires some kind of writing. I'll explain. P of 0 is not going to 1 actually. P of 0 we need to calculate where x equal to 0. Suppose if we take this example, we need to calculate P of 0. That means what? Here x is 0. Right? 6 is 0. 0.5 whole power x, that means 0. 0.5 whole power 6 minus 0, that is 6. That means 6C0 means NC0 is always 1. 1 into 1, and here you will have 0.5 whole power 6. Okay? So it is not going to be 1 always. P of 0 we need to calculate. Just like P of 1 means x equal to 1. P of 0 means x equal to 0. Like this, we have to calculate probabilities at every value of x, including 0. Next is Poisson distribution. So Poisson distribution is another distribution where its probability distribution function is defined as e power minus lambda power x by x factorial. So here this lambda is called as the parameter. This is right. Now I think I repeatedly I have been saying expressing. So very important to identify what are the parameters when we go for implementation. So in case of binomial n, x, p are the parameters. In case of Poisson distribution, lambda is the parameter. Okay. So when maybe I'll explain like when we have to go for what is this lambda, when we need to go for Poisson distribution. I think we'll see in the next slide. Before going, whenever we talk about random variable, whenever we talk about distribution, I already told mean and variance are two important terms for us. Okay. Then, in case of binomial distribution, mean is NP and variance is NP. In case of Poisson distribution, mean as well as variance both are equal. That is nothing but our parameter lambda. So that means this relation between mean and variance are very important for us sometimes to model the given scenario. That means for a given scenario, which one is better distribution, whether binomial distribution or Poisson distribution, which one is the opt distribution we can fit into the data we are working with. So for which this is very important. That is, we'll find mean, we'll find variance, and we'll try to find a relation between these two. Suppose we observe mean and variance are the same. Right? After the calculation, we'll find mean and variance both are the same. Then we say, boss, it is very good that we can go ahead with Poisson distribution. Right? Otherwise, if mean greater than variance, right? If it is mean greater than variance, then we say better model the given situation or given data with the help of binomial distribution. Okay. If mean less than variance, that is next question, right? Then we have to look for some other distribution. Right? As far as these two distributions are concerned, so these are the relations: mean equal to variance, Poisson greater than mean greater than variance, binomial distribution. Right? So when we have to, right? I think so I think both are very clear. So when we have to apply this Poisson distribution, actually Poisson distribution is nothing new. Just we'll discuss now. Apply the binomial distribution, right? We know what is the mean of the binomial distribution, NP, right? We know mean of the binomial distribution is NP. Suppose n is very large and p is very small. N is very large means the total number of trials are very big and probability of success is very small. Then if you see, if I find n into p, then almost it behaves like a constant. It is like n equal to 1 lakh, n equal to 1 lakh and p equal to 0.01. If I multiply n into p, and now 1 lakh becomes 1 lakh 1, 1 lakh 2, 1 lakh 3, then also almost it behaves like a constant. Therefore, we say it is a lambda. Then I am not showing derivation here. The actual binomial distribution NCX, p power x, q power n minus x, whatever is there, we approximate. If we use this concept, then finally we'll get this. That means Poisson distribution is an approximation of binomial distribution. It is the one which is derived from binomial distribution with the conditions n tends to infinity and p tends to 0. Just try to remember this only. And if you remember, when we say it follows Poisson distribution, when n is very large and p is very small, N is very large and P is very small. What does it mean? It is the rarest of the rare events. Right? Rarest of the rare events. Suppose if you say in maybe in a metropolitan city, on the whole in a year, suppose 10,000 people are dying, N equal to 10,000. Okay? And here, suppose if I consider the death because of some snake bite. Right? So out of 10,000, what is the probability? It's almost very small, maybe 1 or 2 cases. That means it is the rarest of the rare event happens. In such cases, it follows Poisson distribution. Okay, I hope that is clear. Mean less than variance, that is a different scenario. We'll look further to find out. And many distributions are there. With mean less than variance, what happens? And we can think of its visualization. If mean is something and variance is less than that, whether it fits into or not. If you, I think you remember what is meant by variance. Variance is something where mean will be there, and how that points, data points are scattered based on this mean. This is what we call as variance, right? It may be positive side or negative side. So mean and variance, this is. So what we are talking about is both are the same. Mean and variance are the same is one case. When mean is greater than variance is the other case. Third case is less than. In case of less than, we have to think of other ways of fitting the model into the data what we are working with. That I think maybe in appropriate time we'll discuss that scenario. No, this is not Gaussian actually. We'll see. Okay. So next is our important distribution, that is Gaussian distribution or normal distribution. So here I think we'll take for 1 or 2 minutes, 1 minute, then we'll continue for we'll continue and we'll try to complete normal distribution.